Hello everyone, Mr. Fawcett here, and we are back with another Algebra 1 lesson. Today we're going to focus on multi-step equations. So we've done one-step equations, we've done two-step, and we've also done equations with decimals and fractions. So we're not going to never see those types of equations again, but we are going to build on what we've learned, and we're going to do multi-step, which could mean two-step, could mean three-step, four steps, etc. Before we get into the actual practice, though, I want to go over something that sometimes trips students up when they see these types of equations. So we're going to focus on that misconception. If you want, and I would actually encourage you to do so, I would read through the questions on these two pages and see how many of them you are able to answer. If there's something you don't understand or a question you're unsure of, that's okay. You can come back and listen to the video and the explanations. But I think a lot of you have seen this misconception before, and some of you probably don't make this mistake very often. So feel free to work through these two pages before continuing with the video. Okay, so let's start off. It says, how many of you have heard a math teacher say the phrase, quote, "you can't add apples and oranges," end quote? Well, today we're going to investigate it and talk about what it means. And hopefully this is the last time we really have to go into depth because you've probably heard this before. So part A says, how many total apples are there? It's not a trick question. All we have to do is count the apples, and we see that there are 6 over here, 2 over here, so that's going to be 8 apples total. Oranges, we also have 8, right? We have 5 here, we have 3 here, so that is also going to give us 8. Part C says, why can't you include the oranges as part of the apples category? Again, this is not a trick question. It's strictly because an orange is not an apple, right? If your mom asks you to go to the store to pick up, 10 apples for the family, you're not going to get 8 apples and 2 oranges, right? She wouldn't accept that. She would accept 10 apples. So this is going to kind of lead us into something to do with numbers and variables. And we're just going to put they aren't apples. Okay, let's move on down. So as simple as it seems with the fruit example, numbers and variables work the same way. Now you'll see the same diagram, but you'll see that the apples now represent x's. And I'm just asking, how many x's are there? Well, the only things that you should be counting for the x's are this group of apples, which are x's, and this group, which are also x's. So there's only 8 x's, right? There's not 16. We're not adding the oranges in with the apples for the x's. We're keeping them separate. Okay, next page. So let's take away the fruit completely now. I know the fruit seemed like a very easy example, but it kind of sets the foundation for what we're about to discuss with this problem here. Part E says, what are the only terms you can combine on the left-hand side? Combine them and write a new equation. So again, if you haven't done this, pause the video. Try to combine as many terms as you can from the left-hand side. Well, if we think back to this concept that you've probably heard of like terms, right? We can only combine terms that have the same variable or terms that are only numbers, right? So in this example, we can combine the 7x and we can combine the 2x, but we cannot combine the 3 because that is like an orange, right? The 7x and the 2x, those are both apple terms. They both have an x. The 3 does not have an x, so that has to stay separate. So our new equation becomes 9x plus 3 is equal to 5 plus 10x. Okay, part F, it says if you want to then take away 3 from both sides, which term on the right-hand side can you take 3 away from? So we've already combined our like terms. Now we need to start using some inverse operations. So they're saying, okay, let's subtract 3 from both sides. Well, I need to subtract 3 from the 3 to get rid of it, to simplify it. But should I subtract it from the 5? Or should I subtract it from the 10x, or maybe both, right? Think about how you would explain to someone which term on the right-hand side you would subtract your 3 from. Okay, well, I can't subtract them from both because otherwise I'd be subtracting a total of 6 from this side, right? And only 3 from the left-hand side. So it can't be both. That would make my equation unbalanced. So which one do I subtract from? Do I subtract from the 5 or the 10x? Well, it's the same thing, right? If I am subtracting 3, the 3 is just a number. So I have to subtract it from another number. I can't subtract it from a term with an x in it because that's like subtracting an orange from an apple. You just can't do it. So now we're going to just continue to solve this equation. So if I solve, I'm going to get 9x is equal to 2 plus 10x. I need to get the x's on both sides, right? Because I want the x by itself. So I'm going to subtract 10x from both sides. 9 minus 10 is going to be equal to negative 1x, or just negative x. And then I'm going to have 2 on my right-hand side. Okay, again, if you're confused about the algebra, just pause the video, think through it a little bit more. My last step would be to divide by negative 1. I'm going to come over here. That's going to give me x is equal to negative 2, because 2 divided by negative 1 is negative 2. Okay. The reason we have to divide by negative 1 is because this negative x right here really has a negative 1 in front of it. We just don't have to write it. Again, if it doesn't have a number in front, it's assumed that that number is 1. So we divide by negative 1 to get rid of the negative 1, to simplify it. Okay, you guys have a question to look through. And this is one of those you try to catch the mistake type of problems. So Jackie attempted to solve the equation below. Check to see if she made any mistakes. If she did, explain what she did wrong and then solve it the correct way. So again, pause the video, come back once you found the mistake. Or maybe she didn't make a mistake, but if she did, correct it and solve the equation correctly. Okay, so let's see what Jackie did going from step 1 to step 2. Well, it looked like she combined these two terms right here, right? The 4x and the negative x to get 3x. Everything else stayed the same. The next step, to go from the second to the third, she added 10 to both sides. Now she added 10 to the negative 10, so those simplify. And then she added 10 to the 2x to get 12x. And hopefully we picked out that this is our problem, right? These two terms right here are not like terms, right? They're different. One has an x, one doesn't, so we cannot add them together. What we should have done is add the 10 to the 18 instead, because those are both like apples. Those are both just numbers without any variables. So let's rewrite this and just solve it correctly. So we have 3x minus 10 equals 2x plus 18. Okay, so we're adding 10 to both sides. So I get 3x is equal to 2x plus 28. 18 plus 10 is 28. Then I'm going to subtract 2x from both sides. And that's going to give me x is equal to 28. So again, just a small mistake she made gave her a much different answer than what we should have gotten, negative 2 versus 28. Okay, this is going to wrap up the mini lesson. We are going to go do a couple of practice problems. So let's get out that practice sheet. We'll head over there, do a couple, and then we'll be done with the video. All right, so there are 25 problems in this practice set. The first 10 are easier than the last 15. So they get significantly harder as you get to the end of this packet. So I'd work through the first part first and then see if we can do the complicated ones at the end. We're going to do we're going to do number 2 and number 11. So we're going to do 2 problems, one of each type, and then hopefully have enough info to do the rest on your own. All right, if we look at number 2, and actually let me make this a little bigger for us. There we go. Okay. So number 2, we need to think about, can I combine any like terms? So before you do any inverse operations, it's generally going to make the problem easier if you can combine some things. So let's look at the left-hand side. I've got a negative 9p, and I've got an 8. Oops, let's do that in a, meant to do that in a square. Got an 8, and I've got a 1. So sometimes this helps when you're first learning about combining like terms. I'm just doing circles around the p terms and squares around the number terms. If you want to do different colors, that's also fine as well. So I can combine my 2 squares because they're the same type of term. They're both just numbers. So I'm going to get negative 9p plus 9 is equal to 18. Okay. Now I can start using my inverse operations. I'm going to subtract 9 from both sides. So that's going to give me negative 9p is equal to 9. Final step to get the p by itself would be to divide by negative 9. So I'm going to get positive p is equal to negative 1. Okay, so everything from here all the way down to here was something we've done before, right, with the 1-step and the 2-step equations. The difference was with our initial equation, we just needed to combine some like terms before we did some inverse operations. Okay, so numbers 1 through 10 are pretty similar to this. You just combine your like terms, do your inverse operations. Nothing we haven't really done before. You've even combined like terms before in previous classes, I'm sure. When we get to 11, the problems become a little bit more difficult. Okay, so notice we have some multiplication going on here. Well, we had multiplication in the last problem, but a different type of multiplication here. So let's first think about, can I combine any like terms on the left-hand side? Well, I can't because I have a negative 1 and I have a positive 8m. So those are not like terms, nothing to combine. On the right-hand side, maybe you picked this out right away, but I have this negative 7. I need to distribute that to each term inside of my parentheses. So let's get rid of those for now. It helps me if I draw my arrows, or at least it did when I was first learning how to do this, just to make sure you multiply the negative 7 to both. So I'm going to get negative 1 plus 8m is equal to negative 7 times 1, which is negative 7. Negative 7 times 9m, which is negative 63m. And then the 6 is by itself. It's not in the parentheses, so it's not going to be multiplied by the negative 7. So we already talked about there's nothing to combine on the left-hand side. But let's see if there's anything on the right-hand side. So I have a negative 7. That's just an integer, so I'll circle that in blue. 6 is just an integer, so I'll also circle that in blue. And we have negative 63m, which is a variable term, so I'll put that in a brown box. So let's combine. I can combine the 2 integers. So I get negative 1 plus 8m is equal to negative 7 plus 6 is going to be negative 1 minus 63m. Okay? Nothing left, nothing more to combine, so now I need to start using my inverse operations. It's your choice. You can either move the 8m to this side, or you could move the negative 63m to this side. It's up to you. You'll get the same answer either way. Your equation will just look different. I'm going to move the 63m to the other side. So I'm going to add it, plus 63m. That is going to give me, these simplify, So I'm left with -1 on the right-hand side. Then I get -1 plus 71m on the left-hand side. One thing that may help you, and I've seen scholars do it fairly often, is that they draw a line between both sides of their equations. And again, this can help you just make sure you don't mix terms up. It can help you make sure you're adding or subtracting the same thing to both sides. So if you want to do that, that's perfectly okay. You don't have to. Eventually, I don't think you'll end up doing that. But when you're again, first learning how to solve some complicated types of equations, that may help you keep everything organized. The last thing we need to do, well, not the last thing, but one of them, is I need to add this 1 to both sides. So add 1 to both sides. That's going to give me 0, and then 71m equals, again, 0 on this side. Last step would be to divide by 71. And my answer is going to come up here. So this simplifies, and I get m is equal to 0 divided by 71, which is just equal to 0. So m is equal to 0 here. So this problem you can see is more steps than 2 for sure. That's why it's called multi-step. If you take your time though, you keep everything organized. It's not anything different than you've done before, right? You've done distributing before. You've combined like terms before. If you haven't, you're learning at this point. And we've done inverse operations before. So take your time, keep everything in order, and you should arrive at the correct answer. Okay, enjoy the rest of your day, and I will look forward to seeing you next video.